So quick review, we said we're throwing a ball straight up with an initial velocity of 32 meters per second. So we said that was VI. Then we said, how long does it take for a ball to reach its maximum height? We said there's something else we can assume. If we're throwing something straight up, at the top for a split second, how fast is the projectile traveling? 0. We can assume V final is 0. Oh, and it's in free fall, negative 9.8. Wait a minute, it's moving up. Yeah, I know it's moving, its velocity is up, but it's accelerating down because it's slowing down. And we've defined up as positive and down as negative. It is slowing down. We said then we could also find the maximum height. Oh, and for those of you that were away, I like example 3, I like example 3, I like example 3. Example 3 is a nice question. And we got to part C. How long is the ball in the air for? Now, normally I would not bother re-deficking Natalia because I have it all on the same page. But since it's been a weekend, to jog our memory, let's first of all say, hey, what's this question asking me to find? What is part C asking me to find? How long? What's that? Time. Let's write down T equals question mark. We're throwing something in the air, it's in free fall, so I can say I know this. What's the acceleration? Hello, what's the acceleration? Negative 9.8, that's 1g. By the way, when they talk about g forces, if you ever hear that, like when you're watching a science show, or it's actually, they mean g accelerations. It's not a force, and each one is 9.8. So if they say 3 g's, 3 times 9.8 is, I think, 27 point something. You're experiencing an acceleration of about 27 meters per second squared. Humans can handle 6 Gs okay. 10 Gs is survivable, but you'll probably crack a rib and probably black out. We'll talk. People have survived bigger than that, but with horrendous injuries. What else? Oh, I told you in the question what VI was. Yes? What's VI? 32? And I know one more thing. I know VF, and it's not 0. That's after I hit the ground. When I hit the ground, how fast am I traveling? And this goes back to my rant earlier. What goes up must come down. Because we're starting and ending at the same height, Carson, we can do this. So I'm looking for an equation that has T, A, oh yeah, you probably want your yellow formula sheet handy, VI and VF. Thomas, which equation? Kyle has his formula sheet. Look over, or get yours out, but you can't just sit here and absent-mindedly hope I'll do it for you. No D. Yep. Okay. Good. Now, ready? Look at the equation. What are we trying to get by itself? Ready? I'm going to do this. We're going to see if we can do this in our head. See the T in the equation? See it, see it, see it, see it, see it? What else is on the same side as the T? How am I going to move the A over? I'm going to do that later. What else is on the same side as the T? How would I move it over? I'm going to see if you can. If you can't, that's okay. Can you read me the equation, getting the T by itself, what I'm going to write? I'll give you a hint. T equals VF. Yep. 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 It can be done. Would I do it that way on a test? Nope. I would always write out the original and then do it. Can you do it that way in your homework? Knock yourself out. If you can get that good in your homework, I think, Danielle, that's a healthy thing. What's VF, Thomas? Good. Caught the negative. Why negative? Because which way is it traveling when it hits the ground? Down. Minus. What's VI? What's A? What are we finding, Thomas? Time, scalar or vector? Who remembers? Time is a scalar, so I'm expecting time to be positive. Look, look, look. The bottom is negative. In the top, I have a negative minus. That's going to be a big negative as well. What's a negative divided by a negative? positive. You know what? The fact that I'm getting a positive time suggests I did the physics and the formula manipulation correct. Now, Thomas, I would get out my calculator. Is there more than one number on the top? Brackets. Is there more than one number on the bottom? Nope. No brackets required. Bracket, negative 32 minus 32. Time of flight. How long is it in the air for? 6.53. I'll go 6.5 because I think I should go to 2 sig figs. 6.5 seconds. That is one way to do this. There is another shortcut, and the only reason it's a shortcut is because we had already done part A. Can anybody tell me how I could have used part A to find the answer to part C? Now in A, we found how long it takes to get up to the top. How could I have used that to figure out part C? Yeah, Kyle. So you're saying I could take part A and times it by? Double it. Now, the reason I didn't do that, even though that's the short way, is if I got A wrong, I'm guaranteed to get part C wrong. But now, let's suppose this was a test question, and I told you I like this question, and I finished it. What I would quickly do is I would go to my answer in part A, which this is my more accurate one, and I would say, okay, let's see. Does 3.265 times 2, does that give me 6.5? Then you know what? Not only must part C be right, I'm pretty sure part A must be right as well. There's no way, Spence, I could have fluked out and got it 2 different ways, the same answer. So let's write down here, or part A times 2, shortcut, which was 3, what did I say part A was? 3.265. 265, Mr. Dueck. Oh, seconds, and then I wrote a little. I put a little happy face to say, "Yay! I know I'm right." And we're already. I've only given you 4, call them equations. We're already at a stage where we can do things in more than one way. Eventually, you'll have many options. D. What is the impact velocity just before it hits the ground? We already answered that. What does hit the ground at? Kyle, you're on a roll. Spit it forth, my friend. Negative 32. That's V final. And again, Riley, one of the most common errors I see, and even my physics 12s are doing it, and I'm trying to beat it out of them. Oh, V final is 0. No. That's after it hits the ground. And that's a boring, trivial answer. Yes, for anything that we throw into the air, eventually its final velocity after impact is 0. I'm not going to ask you that. When I say find V final, what I mean is, hey, tell me what it's hitting the ground at. E. What's the displacement of the ball once it hits the ground? This is a trick question, so easy that it's tough. Remember, displacement is your change in position. How high was the ball when we started? On the ground. How high is it when it finishes? On the... What's its displacement? 0. Yeah. By the way, its distance... Oh, you know what? Instead of writing the word distance, I'll just put a D without a vector. Is how high did the ball go? We found that, I think, in part B, didn't we? Right? Its distance is whatever your answer was for part B times 2, because it went up that far and came back down that far, but its displacement is 0. Oh. Physics lesson uploading in the background. Next page. Let's put it all together. The only problem with example 3 is when I throw something, it actually isn't on the ground, because I'm not laying down with my belly on the ground when I throw it. When you throw something, you're standing up. So a baseball is thrown straight up. Check. It leaves the thrower's hand 1.6 meters above the ground at a velocity of 16.2 meters per second. Okay. Now let's be a little more accurate, Riley. We'll throw it from 1.6 meters, about this high. Okay. Alexa, what's A asking me to find? How long, right? Is that V, D, T, or D? D? That can be, because there was a question we did earlier where I said, how long is the runway? But I think in this case, by the way, I'm not a big fan of the phrase how long. On a test, I rarely use it, but in your homework, I will, just to get you thinking. Is this asking for a distance if you read the question, do you think? No? What do you think it's asking? How long is this? Time. So let's write down. All right, let's defic. What else do we know? What's that 16.2? VI is 16.2. Oh, I know that. Sorry? Negative 9.8. And then who remembers from last day the fact that we're at the top? I know something else. VF. All right, looking for an equation that's got T, VI, A, and VF in it. Which one? Oscar, my friend.
VF equals VI plus AT.
Think you can get the T by itself in your head? Let's see. Give you a hint. T equals, so now go look at the equation. See where the T is sitting? What's on the other side that's going to drop down like a domino? What's not going to move at all?
It's going to be...
Don't cheat off of... You need to learn this. Don't be looking at Carson. It's not helping you. Look at the yellow sheet.
Yeah.
Grab it. You got the equation there, right?
Yeah.
Okay, what's on the left-hand side that isn't moving at all? I think the VF drops down like a domino, right? Okay, what else? Always do the addition subtraction parts first.
Minus.
Yep.
VI.
Yep.
Divided by
Yep.
A.
Yep. And by the way, we used VF equals VI plus AT. Do you have to do it in your head like, no? It's kind of cool, though. Don't you get a little nerdy adrenaline rush? Keep going, Oscar. You're on a roll. What's VF?
0.
Yep. If you take the time to list your data, it becomes plug and chug. And I know listing the data, that's, you know what? It's about 1 second's worth of work. It's good bang for your buck. Minus 0.2.
Divided by negative 9.8.
I'm finding time. I'm hoping for a positive answer. Oh, the top is negative. The bottom is negative. It's a negative divided by negative. I will get a positive answer. Oh, 0.2 divided by negative 9.8. 1.653, blah, blah. I'm going to write 1.653, and then I'll do sig figs. So let's see, 1.653. Now, they gave me this to 3 sig figs. The negative 9.8, that's actually accurate to about 4 sig figs, if we want to. So I'm going to go to 3 sig figs. I'm going to go 1.65 seconds. Again, if you said 1.7, I'd take it. If you said 1.653, I'd take it. But I'm going to emphasize sig figs without taking marks off for sig figs. B, I'm coming back to you, Alexa. What's B asking me to find? Height, which is a distance, and that's the other way you might have been able to reason that part A was time, because otherwise I'd be asking you to find distance twice, which doesn't make sense, right? Height, distance. So Alexa, let's write down D equals question mark. Have we turned the page? This is meant to be obvious. Have we turned the page? No, then since I have the DFIC data listed in part A, I'm not going to read DFIC. I've got it all up there. So I'm looking for an equation that has to have a D in it. And it can have a VI, an A, a VF, and I'll use a T if I have to. Which one? Sure, Oscar. Which one?
VF squared
Yep.
equals VI squared plus 2AD.
Totally works. Or which other one could you use? That'd work. VIT plus a half AT squared. The 1/2 VF plus VI times T. In fact, I got lots of options. I would not take marks off for whichever you use. As a good test writer, I'll usually go out of my way to try and find an equation that doesn't use what I've just found. The only issue with those ones is, you know what, I'd be using T in both of them. Although, what I might do really quickly right now, since I happen to have T stored on my calculator, is I might try going 16.2 times T, answer button, plus a half times negative 9.8 times answer button squared. I think using Oscar's equation, I'm kind of hoping if I'm lucky, I'll get 13.38, 13.4. If I get that with Oscar's equation, then I know part A must be right. And it's a pretty quick plug and chug on your calculator. All right, this is the squared one. This one is tough enough that I usually do write it down. Dev, can you get the D by itself for me, kiddo? Yeah. Is that right? Yep. Plug and chug. VF, 0 squared minus VI 16.2 squared all over 2 times negative 9.8. Sir Kyle, is there more than one thing on the top? Brackets. Is there more than one thing in the bottom? Brackets. Again, I cannot emphasize enough. This one in particular, you all want to practice typing into your calculator, because every year I see the kids write this and then they get some nonsense answer because they haven't practiced typing it in. You should get an answer. Well, let's see. 0 squared. By the way, 0 squared is just 0, so if you just put a 0 there, that's fine. I'll put the squared because it terrifies kids if I don't, but for what it's worth, if you want to be lazy, go ahead. Divided by bracket 2 times negative 9.8. 13.4? Oh, in fact, because I used my answer button, these match exactly using the D equals VIT. You know what? That means I got A right as well. And I get a little nerdy smile and say, good. Free marks. Well, no, I had to earn the marks. Guaranteed marks. 13.4 seconds. Meters. Thank you, Oscar. That wasn't Oscar? That was Devin? Thought it came from Oscar. Meters. Read the question, Dueck. C. What's the final velocity when it reaches its original release point? No work required in your head. When it comes back to the same height that it started from, what's V final? What goes up must come down. Negative 16.2. Now, if I don't catch it, if I let it keep going, when it hits the ground, will it be traveling faster, slower, or the same as negative 16.2? A little bit faster, like negative 17 maybe. I could actually crunch the numbers and find out, but I don't. Did I ask that? Let's find out. Oh, no, I didn't. What is the final velocity of the ball when it reaches? There's no more? We're going to add a part D. Oh, no, wait a minute. Part B is wrong. This is what I meant to add. I remember this now. What did I ask you to find in part B? What have we found in part B? Not the maximum height. We found how high it went above his hand. How high was his hand off the ground? So this is nice. I don't know if I'd ask you this one on a test, but to be more realistic, you know what? The maximum height, how about H for height, is going to be 13.4 plus it's already 1.6 meters from the ground. Heck, I can add that in my head. 15 meters. There's the maximum height. I thought I had you guys add. Why did I give you that? And then I went, oh yeah, here. Okay. Homework. Pause for a second here. So what's your homework? It's going to be a little disjointed because of next week. First of all, I have for you here a take-home quiz. Okay. Next class, we're going to be spending most of class doing 3 little mini lab activities. You'll get them all done in class, I suspect. This take-home quiz is due, strangely enough, after Christmas, because I'm not going to mark it with you until then. I told you that next week you guys can be watching a video. This is something that you can put off and work on next week during class if you want, or you might get it done in class. Just hang on a second, Colin. Are you passing them down? Okay, that helps. This is all about acceleration. Okay? Actually, you know what? No, it's all about... I'm not going to mark this next class. It'll be due later. Then I've given you this sheet here called Solving Acceleration Problems. Okay? This has some easies, some nasties. You'll probably have to do, in fact, you do have to do these on a separate piece of paper. I didn't leave you enough room. This is also going to be due after Christmas, but you can work on these. So the first 8 questions, here's your scrambled answers here. A little challenge question for you to answer. And then on the back, it's all about free fall. Lots of free fall questions. Some of these are going to be tricky. Some of these are difficult to do. Which is the one that I want to... Maximum height, time is good. That works. 3, I think I finally fixed. Vertically upwards, velocity, yeah. I think you can do these as well. There's a little graph to interpret. And you can also work on these next week. So you can start them right now. You got a full half hour. You probably get the take-home quiz done in class. Wednesday is labs. Next week, videos.